Now that you've seen the single index model worked out on paper, I want to go through in Excel and let you see the actual results. First of all, we need alphas for each one of the stocks. I'm just going to make these up because your analyst for Abbott Labs would say the alpha is 1%. The analyst for Best Buy may say 0, 2% for Chevron, 0.5% for Delphi, and 1.5 for eBay. So that's completely, I won't say made up, but those are given to you by your analyst. And I have those in blue and bold just to emphasize that those are typed in. Those are not formulas, those are just typed in. The same thing with the market risk premium. Your chief economist would say, I think the market risk or equity risk premium should be 5%, and there it is. So the market variance, we're going to assume that the market variance is constant over time, and we have two ways to come up with that number. Here's the market data. So the first way, I can come in here and I can say it's equal to the variance. So I'm going to use the sample variance here for no particular reason other than I just choose to do it that way. Highlight all of it, multiply by 12. Not divide by 12, but multiply by 12. And remember that number 0.0183. The other way I can get to this is looking at the regression output. And I want you to be able to do this with the regression output. I would have here equal to the total sum of squares divided by 59, because there's 60 observations and 60 minus 1 is 59, minus the residual divided by 59, all divided by the beta, which is going to be down here, the beta squared. Now that number is the monthly market variance. I still need to annualize this, so I'll multiply that by 12, and there's my market variance. Okay, so the next thing I need to do is put the betas in for each one of the individual stocks, and I'm just going to reference the beta that was calculated by the regression. And the way I run these regressions, by the way, I go to data analysis, and then do the regression and highlight. Here's a highlight for eBay, and then the X range would be the market, and you have the output wherever you want it. I've already done all of those, so you don't have to go, I don't want to go through that step by step. So I'm just going to choose the betas that were the result of the regressions. In real life, I may want to do something, I may want to adjust those, have more thought into it, but we'll just go with those outputs. And that's the Best Buy one. Then I need the one for Chevron, which is down here. And then I need one for Delphi, which will be right here. And then I need the one for eBay. So page down until I get to the eBay. And there's the beta for eBay. So now I have all the betas, all the alphas. My expected return is going to be equal, and these are excess returns. It's going to equal to alpha plus beta times the market risk premium. And I'll lock that down because the market risk premium is the same for all of them. Copy this down. And now these are not the historical returns. These are the expected returns, and there's a difference in those. So let me just show you what those are. So if I come down here, equal average, page up, close parenthesis times 12, bring these across, and just to show you what the difference is. Now that we're going to use these, but just to show you what the difference is, I'll put them right here temporarily. So just pay special, transpose. I need to pay special, transpose, and values at the same time. So that's going to give me a percentage, 15% versus 3, 12 versus 9, 12 versus 7. And this is kind of the big one, 5 versus 44, 5 versus 20. So I'm not sure that these alphas are right, once again, because they're made up. Maybe I want to change this to be something bigger. But anyway, that's going to be a much closer estimate to the truth than saying history repeats itself. So the big point is, this is what you got from just raw historical returns. I want to get rid of those. And this is what our analysts are predicting. So now I need to have the covariance matrix. And the covariance matrix will be set up something like this. For Abbott, it's going to be the variance of Abbott. So I can come down here to the bottom. And this is going to take a little bit of time. So I'll show you how to do it, but I won't go through each and every one of them. So this again is equal to the variance. We used sample before, so we're going to stick with sample. The variance of that whole thing, so period, you can page up to come to right here, times 12, and here's my variance for each one of these. So those are the variances for the different stocks. I'm going to pause and put those into the covariance matrix where they belong. Okay, so now I have all the covariances, the variances of the individual stocks put in here. And notice I just referenced the cell where they were calculated. One other note, with Delphi, since all of these are blank and I don't have a space in there, like if I put the space they could change something, but I actually have cleared the contents, so there's nothing in here at all. Just to double check that, you can clear the contents. So it doesn't matter if I reference at the bottom here the entire thing, and I'll show you what I mean. It doesn't matter if I reference all the way from row 3 to row 40 or row 62, or if I just start where the numbers are, because when Excel sees those are blank, it doesn't do anything with them. It just looks at the cells where there's a number. So those variances are like what I've had before. The covariance is going to be the difference here. So the two main differences, the expected returns and the covariance is going to be different. So the covariance is going to be equal to the beta for Abbott and Best Buy. I'll just do one of them here and then show you the numbers later. So I take the beta for Abbott times the beta for Best Buy times the market risk premium. Times the variance of the market. So those three, this is the beta for Abbott times the beta for Best Buy times the variance of the market. That is the covariance between Abbott and Best Buy, which is the same thing. Which is the same thing as this. So then you just go through and fill in the entire covariance matrix. So I'll pause and do that. So rather than pausing and doing that, let me show you a faster way to do it. So I can say equal, because I have the betas right here. I forgot to put them right there. The beta of Abbott, and lock that down, that's F4, times the Best Buy, times the market variance, and lock that down by pressing F4. Then I can just copy this down and just double check that I have this right. So there, beta times the market variance. So same thing with this one. This is going to be the beta of, we have CVX and Best Buy. So I'll start with Best Buy. These don't change. So lock it down times, I'll go ahead to the market variance and lock that down, times the CVX beta, copy this down. So I will pause to get the rest of these filled in, because right here I just need, this is going to be equal to this, right? So I'll pause real quick and get those numbers filled in. Okay, so now I have the risk, return, and relationship, right? This is the risk and the relationship of the stocks. This is the expected return of the stock. So I use these returns in this covariance matrix, and I go ahead and build the efficient frontier, the asset allocation, the exact same way I did using historical data. So I'm not going to do that here. I'm going to leave that for you to do. But that is the key to the single index model, is that all I need to have are the alphas, the betas, the variances of each one of the stocks, so the variance of each stock, and these two numbers. So this is going to make it a lot easier to do, a lot more accurate, and it incorporates new, more accurate data than just looking at history. So that is a basic single index model implemented.